Hello Linux lovers, my name's Wimpy, welcome to my world. Today we're going to be enabling hopefully the NES Pi 4 case for Retro Home. Good morning Paul, how you doing? So that's the iconic NES styled case that you can use to put a Raspberry Pi 4 inside and then, load that Raspberry Pi 4 up with emulation software, which is what the Retro Home operating system that I've been working on is all about. I'm not sure how far we're going to get with that. Hopefully we'll get it all working, and if we do, that should open up quite a broad range of the RetroFlag cases. So that's where we're going to start. If you're watching this on YouTube after the fact, this was originally streamed live on twitch.tv/Wimpy's World. So if you want to join in interactively with the rest of the community, then give us a follow over there, please. I stream every Monday, Wednesday and Friday. Hey Paul, you've just finished making your tea. That's good. I've had a cup of coffee, but now I'm having my cup of tea. So, let's just take an overhead view here. So I've removed my usual dev machine here with the NES Pi 4 case. And why do we need to do any work for this? That's because it has two buttons on the front here for power on and off and reset, and that's connected. Those buttons are connected to the GPIO pins on the Raspberry Pi, and we can then implement some drivers to pick up those signals to do a safe shutdown rather than simply cut the power. So we can intercept the power off button being pushed when the device is on, initiate a safe shutdown. So that's what we're going to be working on, and the next question should probably be, well, why the heck do we need to actually implement our own drivers anyway? And for that we'll just head over to the RetroFlag website and we'll take a look here. So this is their GitHub repository for their case drivers, which are implemented for the sort of set-top box style cases and also their handheld cases. And if we just open this one here, Safe Shutdown, this is the issue right here. So rpi.gpio is a Python module to allow you to address the GPIO pins on a Raspberry Pi. But since Linux kernel 5.11, the mechanisms of accessing the Raspberry Pi pins have changed, and these mechanisms simply do not work anymore. So last year I did some work to port these drivers to a GPIO library called GPIO 0, which can address the GPIO pins using the contemporary APIs such that they work. So I think that work's done. We'll have to revisit those drivers because we worked on case drivers for the Desk Pi recently, the Desk Pi Pro and Lite, and we found some ways to improve them. So we'll incorporate some of those improvements into these drivers. But the plan for today is we get a build of Retro Home working for this case, which gets the power on, power off and reset buttons working. And then for bonus points, we'll see if we can get the LED to work, and I'll come back to why that's an issue in a moment, and also get the SATA caddy. It's got a flip top thing here, and you can slide in one of these, which is a cartridge styled SATA enclosure, 2.5 inch disc enclosure, and this one has a SATA SSD inside it. You could put spinning rust in there as well, and the idea is that you can put your OS on this and boot off this rather than the card round the side. So we're going to try and get all of the options working, booting off the micro SD card, but then booting off this. But then why is that even an issue? Well, it turns out the firmware for the Micron controller in this device is a bit buggy, and with recent versions of the Raspberry Pi firmware updated, it degrades the performance significantly. So you need to instruct the kernel to ignore some of those protocol negotiations in order to sustain the best performance that it can. So there's this. The reason I'm doing this case is it's the most fussy of the ones that RetroFlag have made, that don't have any like interesting hardware. So I've got some handheld cases of theirs, and I have a PlayStation case with an embedded screen. So I'm going to come to those a bit later, because if I can get this one working and all of its quirks, then it should work on a bunch of the others, and I have some of the others here. So we have this one, which is a Mega Drive styled case. This one doesn't have anything clever about it other than the on-off and reset switches, which use the same GPIO drivers, and there's some more NES styled cases which are similar down there. So if we can get this one to work, the others should follow in fairly short order. Hey Diogo, how you doing? And also hello Esme, how are you doing? I think that's what we're going to be working on. There's a new chat command for people new to the channel, so I'll see how many people spot that. I'm going to add some more little chat integrations as well. There's also another one here as well. I'll see if there's this. There we go. Oh, there we go. So see if you can find that one. Right then. So let's get on with this. Let's take a look at some code. I see you hunting. See you hunting for the commands. So we were just looking at the old drivers there. So let's just refresh ourselves on what cases we're looking at here. This is the case I'm going to be working on today. But if we just take a look back here, this case without the screen, I think should work with the same drivers. I have this case. This should work as a result of the work. This is the case we're working on today. This one should also work, as should this one, and this one, and this one, and even this one. I don't have this, but I do have the others. So hopefully, all but the Pi cases, there's a bit more work involved with those, but we will get to both of these cases with compute modules, with Raspberry Pi Zeros and compute modules. We've got 3 versions of those we're going to work on. And then this one, I think should work without any fuss or mess, but we will find out. New commands need hunting down. Indeed they do. Let's go and so in the project that I'm working on is Retro Home. This is where the build scripts for my Raspberry Pi operating system are. Now what I'm thinking is, once I can open up a bunch of these RetroFlag cases to work, I think at that point I may spin a refreshed image to download from here. So a generic image for the Raspberry Pi and a RetroFlag image that covers a bunch of those cases, because I think that demonstrates that, because we've done all this work to get the underlying OS in good shape, but it's really close to actually being actually useful, even though there's a bunch of improvements I can do with like the actual emulation side of things, which is going to come in the future. It'll be nice to actually get these things working, and apart from anything, the state of where things are now is way better than the janky version I have on some of our set-top boxes at home and at my niece's and at my in-laws. So I'm keen to with the summer holidays approaching, I'm keen to get this in a better position so I can go around and update everybody's consoles. So code, let's go and take a look here. What are we going to be looking at? So I've quickly added a new name for the NES Pi 4 because that was absent, and in the interests of time I'm going to disable the desktop on this one today just to speed up the build times, and I have already run through the build steps to get the cache warm. Good morning, Takov. How you doing? Hello, it's only a gnome. I don't have a command for that, but that's a good idea. It's only a gnome is requesting coffee with chat commands. I hadn't considered that, but yes, I think that's not a bad idea. We can work with that. No items found. Oh, you're issuing a bunch of commands here I'm not familiar with. Right then. So we've added that stanza in, we've built the thing, and if we go up here, we have, from about 6 months ago, we have some stuff here for the RetroFlag cases, which is to install the necessary Python modules, and then we have a script. And now I've slightly changed the way the case support is organized in the Git tree. So what we'll do is we will reorganize the RetroFlag project in the new way, so that I want to keep them more discreet. Well, I've turned a bunch of the default ones off. It's unusual. It's odd that it's telling you about commands that I haven't published, but I can look at that. I thought it'd be fun to try and liven up the chat stuff. So let's take a look here. So this is a generic statement. So I think what we'll do to start with is if we just take a look at the RetroFlag in air quotes driver. So this is it. It's a Python script, and as you can see, we're using GPIO 0. This was originally created by Ben Nuttall, who used to be sort of the community manager and many other hats at the Raspberry Pi Foundation. And he created this as a means to make it easier to program the GPIOs, particularly when you're teaching children how to do that. And I learned about GPIO 0 at a talk he gave at OggCamp a few years ago. And I've been using it ever since I learned about it. And in fact, at my local hackspace, I've given a version of Ben's talk about GPIO 0, which is interesting because it always draws in people who don't normally come to the hackspace, because we advertise in the local press, and we get a lot of parents and their kids turning up for those ones. It's pretty good. So let's just remind myself how this works. So we have a main entry point. These are lining up the pins that we need to use. There's the LED, which I think we're gonna, I've read doesn't work properly. So for those of you that have been here recently, I know King Egypt was asking about this. This case is very quirky, and I was trying to remember what the quirks were. And so to recap, the quirks are in fact that the power LED lights on the NES Pi 4 case don't appear to work when you have the SATA SSD enabled, although that seems to be an interaction with recent versions of the Raspberry Pi firmware. So we may have to update the firmware this morning as well on this device to see if we get any improvement in that situation. The other is the Micron controller for the SATA SSD in this case has bugs with its UASP support. So we have to enable quirks in order to try and preserve as much of the performance as that drive offers. If we don't do that, it will go down to kilobits per second transfer speeds, which will be very disappointing. I see you're enjoying finding all the cat chat commands. You have fun with that. So that's one of the quirks, and then I think that's kind of it. So we've got this code here, and then we set up the buttons here and bind to the reboot, so when held, so the reset button when held. This is one of the nice features of GPIO 0. You can easily program these distinctions between a button being held down for a period of time or a button being double pressed, or just a a single release and a press. So we actually have to hold the reset button for a reboot to happen, which I added because I quite liked that. And then power off is what it says, it'll issue the power off. So if we look at these two functions, they're very simple. It calls button dispatch, one for reboot and one for power off. So when we look at the button dispatch here, it tells the LED to blink. I shall be interested to see if that actually works. I know it will work on some of the other cases without the SSD in it. It then kills Ludo, which is our front end, and the reason it does that is because that will actually close out like the that session, and that will sort of make sure that that session is flushed out. And then it sleeps for 2 seconds. I wonder why I've done that. I wonder why I did that. I can't remember. And then it issues the command that we've passed, so either the reboot or the power off. And then this is a simple thing to iterate over the processes and kill the ones that match the name. So something that we added in the other, and this isn't a long running, oh, it is actually long running. So this will be started via this one, in fact. So in the build script, we changed this line here to match the case that we're building for. Esme's found the new thing. I haven't quite figured that one out yet, Esme, about how to pass in other names. So what I'm going to do is I'm going to pull this out. Instead of being a generic service, I'm going to create one that's specific to each of the drivers. So the reason this is long running is so that this runs as a service and is monitoring these buttons all the time. And I'm going to get this implemented now based on the driver that I have, even though Takov has got a PR which adds some support for a different case in a style which can use evdev and things of that nature. So we'll adapt these drivers, but this is functional, or at least I hope it is. We'll find out. We'll get to test it, but first we need to reorganize things a little bit. So if I just in fact, let's do this over here. If I tree case, we did desk pi, didn't we? There we go. So we had a udev rule there. So we're going to need to create a new config.txt and a new command.txt for this case. So let's start there, because we may as well start there. Right, so let's start there. We're going to need to case RetroFlag. What have we currently got? Config.txt. So this looks like it's a correct. Okay, this looks accurate, in fact. Okay, so this is mainly the modifications that we need here. Enable the UART. This is what I read from. I mean, I did this a while ago, but if I go back here, you can sort of glean this information from looking at the scripts, even though, as I say, these probably won't work on many systems. So here's the device overlay that needs adding. So this is the power IO fix, whatever that means, and enabling the UART. And then all of this is wrong, of course, because almost nothing these days will pass etc local by default either, because that's not enabled by default in most systemd. It can be, but by default RC local isn't passed in most systemd devices. Well done, Esme. So, it's only a GNOME. What do you expect Bang Tree to do? Right. So that's where I got those changes from. And if we come back here, that's basically the extent of the change we need here. But if we copy our generic command line.txt into the RetroFlag tree and then edit that so we need to add a piece here, and that's this bit here. So this is the USB storage quirks, and I'm going to put all of that in this file so I know what the heck we're doing here. I wonder if I can get away with that, but this article here explains this issue with incompatible or spec incomplete SATA controllers, and this USB quirks is actually to say ignore this particular protocol extension negotiation for this device. And at some point I must have looked at the device IDs for the SATA controller in this. So I'm just going to drop that in. Maybe I'll leave on. I think I need to actually create like wikis in the code. Quirks enabled in. So I'll just leave that there for the moment, but I think what I need to do is create a wiki page in the project. It's bang commands is what you're looking for. It's only a GNOME if you want to know what the various commands available are. So let's now move this. What we'll do is we'll move. Let's just go back to here. So desk Pi power off. So what do RetroFlag call this? I think they call it safe shutdown. Okay, so I think that's what we'll call it. We'll call it RetroFlag safe shutdown. And we'll have to look at how it differs. So let's git mv case use a local bin shut down dot. Why is it called it Pi? Why did it do that? Oh, well, that's curious. Okay, let's get rid of this out of here. Open the correct one. Oh, there it is, called the wrong thing. Let's just get that name right. Right then, and then we'll move in this as a specific service for this case. Good morning, good morning. Oh, sorry, thank you. Not Nocturnal Astro. Thank you for that. I missed the assist at the time, but thanks. Right then, let's copy this service. Goodness me. Let's copy this service to case. In fact, we're going to have to make a directory first, aren't we? So we're going to need to make case RetroFlag root lib systemd system. There we go. And then copy that file into this spot here. Okay. And then we'll edit that one. In fact, we won't even edit it yet. We'll then rename it to something more sensible.
Thank you for the follow old__player.
Thank you for the follow, old player. Welcome to the stream. Welcome. So, doesn't it should, yeah, Twitch is a bit delayed, but it shouldn't be too bad. I've got the ultra low latency enabled because, you know, I'm not playing games or anything. So, feedback from those of you kind enough to give me help is I try to respond to in a timely fashion. So let's call this one RetroFlag. Save shutdown. Again, to keep the naming consistent. And then we'll edit that one. Change the name of the file inside. It's a very simple unit, and we will call this RetroFlag safe shutdown support. It's now exactly going to be that. And then we can close that one. We're not going to be using that anymore. And then the other thing I wanted to do was take a look at RetroFlag again. We're going to look at the Python for this, because this is, again, it's a long running process in that it will start when the system comes up, sitting there monitoring those GPIOs all the time. So a bit like the long running Desk Pi process, we'll in fact what we'll do is we will cheat and we will just go and pinch the exact same Desk Pi, and it was which script? Desk Pi fan control. So in this we'll snap that line there, which is the there we go, that's the correct place to put that. And then what we're doing is we're setting the name of the process. So rather than looking like in the process tree, instead of looking like user bin python 3 space retroflag dash safe shutdown.py, we will rename the process so that it will show up as a named process in the process tree. And the reason that that's helpful is that should we want to kill that process, we can now do so by name without having to find a Python parent process and all of that nonsense. So this is RetroFlag safe shutdown. So that should name the process now, and that will also require a change to this script, because here we will now need to include proc title, which generally I imagine I'm going to need for all of these when I come to re-implement them as well. So let's get that updated now so I don't make a snafu in the future. So we will then take that line from here, because we know we're going to want to enable the RetroFlag service. So you may be wondering, well, where does this, and we don't need to do this anymore, this case support is now unnecessary here, because what should happen is just here we have this section that says if the remix we're building for has a root directory, then copy in that root tree for that case, and if it has any boot overlays, copy those in as well. So again, if we go back to our terminal, if we now tree RetroFlag, there we go. So we now have this overlay, which is something to do with the power IO. We know not what, because this is a compiled device tree object. I haven't found the source for this. Some of the other cases there is source code available for the device tree, and you can actually compile it, which is handy. This is our actual code that does the thing, the actual business of doing the handling the safe shutdown, and RetroFlag safe shutdown is the service. So that will copy that whole tree in onto the root file system, and it will copy this tree in onto the firmware file system. And then each of these, which I'll just need to double check are actually correct. I think they are, aren't they? We were working on this one and I decided, yeah, we've added the quirks there. We haven't saved it though. We don't need that open, so we'll close that one now. Okay, and the other thing you'll notice is that I use sub process as a means to launch processes. This is the right thing to do. It's considered bad form to use like os.system in Python, because it can be subject to string injection and things of that nature. So subprocess is a safer option. So that should be it. I am still a little bit curious about why the heck I felt it was necessary to wait 2 seconds there. You know, I really don't think that that's necessary. I've picked up, what's this one? This is just picking up the button, so it doesn't matter which button's being pushed here. This is the button dispatcher. So why would I want to wait? That seems unnecessary. If I'm holding down reset, we've already waited a period of time. I want to kill the process. That won't take very long. And then I just want the reboot or the shutdown to happen. I don't want to wait for anything. It's those processes do the right thing. So we now no longer need time in here. Okay, that's looking good. Yeah, okay, and pause, that just holds. So these are event handlers basically. So these just sit there and monitor at this point. So this is why we have this pause here. Right then, so I think that code is fine. This should be fine, and we've removed the case support piece. So the case support bit here is still relevant for these two, which we'll get to in the coming days. This installs everything we need. This enables the service. Well, I think what we'll do then is everything that we've enabled is and this is where I need to optimize my build process, because up here's in the kernel stage where I have some bits about copying in case specific configs and command lines. So we'll have to run this from the kernel stage, pick up the config, clean it and produce an image. So that should be the right thing. So let's go and generate an image and then see how we get on. And this has got the appropriate bits. So we do want to do NES Pi 4. Now, these are kind of aliases. These case names are aliases for the different RetroFlag. Oops, okay, so I've got a syntax error now. How have I done that? 578. What have I not closed adequately? What have I done here? Ah, I see what's missing. How did that happen? Okay. There we go. Right. Try that again. Okay, so this will build from stage 3 onwards. So it's going to do the kernel install stuff. Okay, so that shouldn't take too long. So what we need to think about now is how we're going to test this. I think we'll start by putting it on a SD card, and we'll boot off that, and hopefully it should come up. At the very least, we should get a running Retro Home. Then we'll SSH in, check that those new services are running. I think at that point I think at that point we'll just test that reset and power off work. And if that's fine, then I think we'll have a go at putting the same image on here and trying to boot off this and see if that works. And if we get that far, we'll then know what the situation is with this LED down here and whether that is addressable at all. And if it's not, for whatever reason, sorry, I just need to check something there. I will take a look at updating the firmware on the Raspberry Pi to see if getting the latest firmware on the Pi addresses any of these other problems. My fear is it might exacerbate things and make it worse. But this is why this particular case I would be wary of, because whilst this SSD idea is nice, it introduces a number of issues to work around, which is one of the reasons why I thought it'd be good to make like case specific builds, so that if you just want to grab some emulation stuff and have it work, you know that you grab an image from Retro Home and it's all wired up to just work. Hello Tommy, how you doing? Welcome back. Yeah, Tommy, so that last Linux Downtime, for those of you that don't know, I do a podcast with my friend Joe Ressington called Linux Downtime, and we sort of did a right to reply episode, and that came out yesterday. It's interesting feedback we've had about that episode, but all feedback is welcome. So yeah, we in episode 49, we sort of had a discussion about what is or was a Linux distribution, and what will or is a Linux distribution today, and is it really Linux at all? And we then got some feedback that we hadn't framed that discussion in the right way. So episode 50 was a retrospective on how we'd handled that topic. Right then, let's go and see how that build is getting on. Oops, I'm in the wrong screen. Let's do that. Let's push that button. Where are we? So, right, there we go. It's just finished producing the image. So, let's have a go. we'll chuck this in my new super fast card writer. We'll come back here. Let's do it this way. Did that appear on the right screen? It did. So we're going to choose a custom image, and we should have one here called RetroFlag. There it is. Looks the right size. That is the thing, so let's get this written out. Now you may have seen that I've used GNOME disks for writing images in the past. The reason I was using GNOME disks was to get a measure of the performance of the different cards. But it's way safer to use the Raspberry Pi Imager, because it only gives you the offering of those devices which are not actual storage devices in your computer. So it's very hard to accidentally do the equivalent of DDing over your root partition using the Raspberry Pi Imager. And I have to say, even with GNOME disks, I have done that. I have effectively done the equivalent of DDing an ARM operating system over my root file system, and trying to recover from that mess whilst the system is partially living is a nightmare. So use this. It's good for your health, if not your sanity. Right then. Now this is where it's a bit of a faff. It's this card slot is round the side. Oh my god, it's gone in a funny angle. What's going on here? What is going on here? Is that upside down? Okay, it is. Right then, we're going to try and boot this thing, and I really don't know what to expect at this point. So I've pushed the power button in, and no LED has come on. And, well, there's the... Huh. Okay. So it hasn't booted off the SD card. So in which case, I'm going to try writing that image to this SSD. Oh, hang on. This. Oh, it's got there in the end. Oh, I see. So it favoured SSD over the micro SD. Oh, and the LED has come on now. Okay. So the LED is on. I don't know if you can see that, but there's a red LED there now. So we'll let Retro Home come up in the usual way. Good morning, Dust. How you doing? I've added a few more features to my setup that are... Wow, this is slow. What's going on? So this may well be this. Well, no, technically we should have the quirks enabled. Huh. Like I say, not a fan of this case. So hey Dust, I've added a few more bits to my Atom setup using the new features, in particular some chat stuff. Yeah, all good here, all good here. Just trying to figure out why this case is such a swine to work with. So I wonder if that quirks mode then breaks the SD card performance. Ugh. Well, we can test this very easily, I suppose. I mean, this is very slow, or it's not working at all, because technically I should be able to see a boot splash, but if it hasn't, wow. Let's go and see if we can get to the I can't remember the IP address. I have a very unusual networking configuration here. Oh wow, it hasn't even come up. I haven't even got to that point yet. Okay, well, that's a problem. So this is a big fat fail. let's try. I'll just let that carry on. What we'll do is we will write this image out to the SSD and see how we go with that. We'll try that. So where do I need to be? None of these places. So let's run up the imager again. We'll choose our custom image for RetroFlag, and there's our SSD. So it's only us, no one else is listening. Between us, don't get the NES Pi 4 case. It's too much of a finicky thing to work with. It doesn't seem to have been very well planned, thought through. So we've written that out. Let's go back. So I'm still seeing nothing here. Now it could be I've busted my operating system, but at the very least I would expect the thing to boot. So let's we're now going to have to just well, the reset button only works as a. So clearly my drivers haven't come up because the reset button would just like hard bounce the box. And the bootloader firmware is relatively up to date. There is a newer version, but it's relatively up to date. So let's yank the power. Yes, there we go. I think that's it. Ah, wow. There we go. Right then. It's just going to take me a mini moment to actually recover this situation. So I need to be able to hear myself. Hopefully you can hear me now. Okay. Wow. That now you have the audio twice, did you say? Okay. Maybe that's better. I will just talk for a moment and you can confirm that there is only one of my voices now. Hopefully that's just echo. Still echo. Double. What fun. Let's deal with one ridiculous situation at a time. Oh wow, so much stuff isn't working. I think I'm just going to have to abandon this. So there was a full-on power outage. Most of the USB devices are not working. So my Stream Deck isn't working. Obviously there's a problem with the audio interface. And that's just too much to deal with whilst I'm live. So I'm terribly these earbuds don't have a mic. So I'm terribly sorry. I'm gonna call it there early. Maybe if I can unbreak this mess, I'll stream again a little bit later today, but we'll see. So that was fun. Thank you all very much for coming. I'm terribly sorry about that. I'm gonna end it there. And then I'm now going to go away and fix this and figure out why all the power went out. and probably have to go around and reset all my USB devices. So thank you very much for coming. Yes, indeed. The most appropriate redemption as me, indeed. Yes, do adjust your sets because there are problems. But thanks for turning up, and I'll get this fixed. Bye-bye for now. Well, let's see. I don't even think I can push any of these buttons. Let's see. Let's see if I can push this one. I can.